So, everybody ready? Because there's no turning back, because I deleted all the folders. It's the early adopter USD journey at RISE. My name is Oliver Markowski. I am at RISE for 6 years now. I started as a CG soup and then moved into a VFX supervisor position on the animated feature Dragon Rider. And after that, I became the head of 3D.
Moin, my name is Kolja Hübschmann. I'm as well for 6 years at RISE. I started as a generalist, and now my focus is in pipeline development, where I recently worked on integrating USD into our Maya pipeline.
Okay, I guess everybody knows RISE, but that's just the standard fluff that I'm giving everyone. So we're celebrating our 16th birthday this year. That's why we're all pink, because of a sweet 16. Right now, we are 390 artists spread across 5 offices with a headquarter in Berlin and other offices in Munich, Stuttgart, London, and Cologne. We're usually working on 6 shows in parallel, and we're creating kick-ass visual effects for international projects. Speaking of kick-ass visual effects, enjoy our reel.
So we'd like to start by giving a very quick overview of how our CG pipeline was structured and what issues we had to tackle in the past, explaining why we naturally ended up with early adapting to USD for the most recent iteration of our Maya pipeline. Approximately 90% of our CG pipeline is done using Maya or Houdini, with data being constantly exchanged between the two. We use Maya for asset build and animation, and Houdini most likely for FX and rendering. For example, modeling is done in Maya, while surface look dev work was done in Houdini. We constantly exchanging data, packaged in HDA, writing Maya files, writing caches, what produces a lot of data. And yeah, why am I telling you this? After all, RISE has built a robust pipeline over the first 12 years, consisting of tens of thousands of Python files to handle these processes efficiently. So why should we delete all this and rebuild with USD? Our short, rebellious, sweet 16 answer would be to our mom and dads, because we can, but of course we put more thoughts into it that we just tell you and not our moms and dads. The main reason was to have a file format that can operate independently of the software. While in the past we had to write our own scripts and file formats for Alembic, FBX and others, it was always time consuming, creating many data duplications like for Houdini and Maya, and had to be implemented individually in each software. As with USD, every DCC can now, in theory, generate the same output. It is now up to the artist to choose which DCC fits the best for his needs. So it does not matter anymore if he wants to use Maya or Houdini or something else. He can just grab the software he wants. Our shot and asset USD bundle workflow. It might sound strange now, but in our legacy pipeline, we never had this explicit description of asset packages or specific versions of a shot. Shots and assets were always been in flux, and while individual elements would update, there never was this one file that would describe a shot or asset as at a specific point in time. Packaging our assets was long overdue. All the USD features, layering contents of different departments where overrides could be super sparse, animating adjustments from a layout in an animation, like just moving something a little bit around. Also being able to mute these edits and, of course, variants with the crowd workflow of USD, so all these features. Another thing was full dependency tracking. So for a long time we wanted to be able to take a final comp and as easily backtrack to all elements used in that render, like textures, animations, asset versions. While this is not something that automatically comes with USD, as we already were rewriting our CG pipeline, it made it much more straightforward to implement. Because USD has its DCC independent API, we could share a code base, split up R&D tasks, and share workflows across our complete CG pipeline. And last but not least, Material X.
Yeah, Material X is not part of USD. That needs to be mentioned, but it is an integral part that is supported by USD. But so we decided in the first place to use Material X and to go full on it. But during the process of using it, we found out that it is not like, we would not recommend using Material X in your pipeline entirely. So we have many use cases where we needed to fall back to, in our current case, Karma shading, but also we're also using RenderMan. This is also not really supported by RenderMan, so we are like back to render-specific shading. But we hope that all the other renderers, or first of all the Material X library, gets more fully featured, or gets a few more definitions. And what I can say, like RenderMan does not have full support for Material X, but our friends from Autodesk, they also have a renderer called Arnold, which is supposedly fully featured, has fully featured Material X support in USD, but I haven't tested it yet. But that's actually on the list. Next.
So we started mid-2019 with Maya 22, Maya 2020, sorry. We right now use Maya 2022. And with the Maya USD plugin 0.0.2 that we have to self-compile. But there were really a lot of other things we had to figure out before even starting to write the code. how to compose and structure our assets and shots and layer files. There's the general concept out there, but of course everyone is doing it slightly different. We had to switch from a pull to a push pipeline. In our legacy pull pipeline, when artists opened a work file, they were asked if they want to update certain elements in their scene. While with USD, or at least we implemented it, elements would automatically update in artist scenes. But this new auto-update behavior also required us to have solutions for cases when we don't want the automatic update, like something is rendering on the farm, so we need to look into building our own asset resolver for USD. Then with all this figured out, we started building all the concept we had in our legacy pipeline. Artists would complain if we took away stuff from them that made their lives easier in the past, just now better and more future-proven. But it's not only rewriting our Maya core, we also had to rewrite major parts of our CG pipeline in Houdini, the connection to RiseBase, that's our in-house shot grid, speed tree. While we were still running project on the legacy pipeline in parallel, while we developed, we had to make sure nothing breaks while we were developing. Besides that, we had to consider how to convert our legacy pipeline data to USD, because we run TV shows over many seasons where we need to reuse data from the legacy pipeline.
So we started using USD in a production on the last voyage of the Demeter at the end of 2021. After roughly 6 months of running that show, we decided that the state of the pipeline was good enough to switch all newly started shows to USD also. This included Der Greif for Amazon, Ghosted, Guardians of the Galaxy 3, Blue Beetle, and many more. And here's a short teaser of the projects we're currently working on with USD.
Voilà.
So, before we get into the RISE implementation of USD, we need to give you an overview about some of the USD history and terminology. So, USD was the development of USD started at Pixar in 2012. It is already the 4th iteration of Pixar's scene description. So Pixar's already, I don't know how many, 30, 40 years old, so they tried it 3 times already, and now this is the 4th iteration, and it is an invaluable contribution to the open source community, and I think we cannot thank Pixar enough for making this open source and an open standard, because I have no idea how many man hours or man years of development went into this. I have also no idea how many millions of dollars this is worth, and they just gave it out for free. So thanks to Pixar for doing this. After history, of course, we have to talk about a little bit of terminology. There's new vocabulary that we haven't used in the past. So there's a great resource out there. Shout out to Christoph Minard from Remedy Entertainment. They came up with a great book on GitHub. It's also free. You can scan the QR code, which sends you there. If it's a real good resource, like for artists and not for the techie people. And I have just copy-pasted the definition from this GitHub into our presentation because it's really good. So we're going to tell you about prims, layers, layer stack, stage, and purpose. As I said, copy-paste. Thank you, Christoph. So prims is short for primitive and a quintessential component of USD. Prims are the nodes within a hierarchy and can thus have parent-child relationships with other prims, meaning that prims can have other prims as children or siblings or have another prim as parent. Every node in the hierarchy is a prim. A layer is a collection of prims and their properties that can be saved or loaded from disk or memory. As such, it can be considered a savable hierarchy. The layer stack. Each layer internally keeps track of a local stack of layers that contribute to the layer. This stack is an ordered collection of layers used within this layer that contribute to its hierarchy and composition. Speaking of composition, there comes the Photoshop metaphor. So the stage is the composed result of opening a layer. Think of it as a Photoshop canvas when opening a PSD document. All Photoshop layers interact with one another to produce a final image. All layers can be edited, deleted, replaced, etc. But what you see is the result, and that is the stage. Purpose is an attribute that can be used to give a prim and its descendants a high-level visibility flag in context of rendering. For example, if a prim has its purpose attribute set to render, it will be excluded from being drawn in a renderer that only wants to draw proxy prims. In some sense, setting purpose could be considered stage traversal for rendering. Currently, only 4 values are supported by the purpose attribute. One is default. The prim has no special rendering purpose and will be included in all rendering paths. Guide. A prim tree marked with guide is generally used by interactive applications that have asked to show guides. Think of it as a requesting to visualize controller geometry for rigs, skeleton, data, etc. Proxy is usually reserved for a lightweight representation of another object to be used in an interactive renderer such as a DCC viewport. And the render purpose is the final quality data to be imaged, usually enabled for offline rendering or final quality rendering. Variant set. Variant sets and variants allow for authoring a switchable state of a prim within a layer. In the example below, a top-level prim, the example below is not below, I'm going to show that here. In the example below, a top-level prim, nee, jetzt kann ich nicht mehr lesen, bisschen hoch. In the example below, a top-level prim with the name implicits is authored, which defines a variant set named shape. The variant set defines a few different entries, aka variants, that each do something different. When changing the active variant, USD will inject anything that is defined within that variant into the current composition. In our example, each variant adds child to implicits with differing types. One is capsule, cube, sphere, and so on. So what you see here is USD view. That's also part of USD, where you can inspect your USD layers. And in this case, they visualized the variant. So you see it's always the same prim, but on the prim itself, you have a variant with the drop-down where you can just select whatever you want to do. We at RISE use the variants for model variants, so different types of the model, like the standard model, and if you have a destructive version of it, you could put in like the destroyed version as a variant. And what we also use variants for at RISE is LODs. So our models usually come with a LOD with an arbitrary number. It's 300. That's like basically the standard level of detail. And if for some reason you need a higher level of detail where you put extra detail in there, you would add a variant with a number higher than 300. Or if you have you need a low-res representation for rendering, for stuff, for basically for trees. Trees 2 kilometers in the background don't need to be full-blown trees. They can be little blobs. So then you would put another LOD made, let's say 100 or whatever, and then in layout you decide which variant to use based on whatever camera distance or whatever you like. So yeah, as I said, standard model variants or LODs. That's what we do. Of course, you can also do shading or surfacing LODs where you have different shaders applied to the same object, and also switch from clean to dirty or whatever. So that's variants. Back to Kolja.
This is about our basic structure of USD, how we implemented it. As mentioned earlier, we are now thinking about assets and shots in a bundle, where each shot contains different layers where we define an order for. Like, for example, with assets, there's a model. Over this goes the rig layer, adding controls, then grooming got over it, and on top the shading happens in the surface layer. Or for a shot, we define a shot template that gives a basic prim structure. Then the cameras get inserted, and on top of this, these cameras could be adjusted with layout, and some rigs or assets get inserted through layout. Then this goes over anim, where most likely caches gets added, and on top FX caches gets added, and then it comes to lighting. All of these layers have different version that can be pinned. So for example, the model, switch. Therefore, we implement a custom asset resolver, which was initially based on the replace resolver that was open sourced by VFX. What the asset resolver allows us to do is remap an unversioned, what we call master asset USD file, that by default always symlinks the latest pushed version, as we can see in the left side, to any other version of the asset. So in the right side, we can see that when an asset gets pinned, the symlink is ignored, and the asset resolver now maps it to a different path. Because of the pinning and the push pipeline in general, it is hard to tell what version of a layer is exactly used. So we use the asset info, which is a USD native property to store custom informations in a dictionary. With this, through the layering system, we can always determine what version of a USD asset is loaded and what layers it's containing. So here in this screenshot, you can see in the top left, way small, we selected the asset root prim. This gives on the right side in the attribute editor the information about the asset info that we put in the script editor, where you can track down all the layer and current that are currently used in the asset USD. But as you can imagine, in a complex scene with a lot of these asset prims, this is not really user-friendly, so we built a pinning UI, giving better control over what version is used and informing the artist over updates. Therefore, we use this asset info to save database loading, while being able to show detailed information to our artists. On the left side is the actual pinning window, where you can apply pinning if you wished to pin it something to a specific asset version. Otherwise, it contains information about the update data, like what version has been in that scene before, what is right now inside the scene, and if pinning is applied. In the middle section, we show the artist the actual layers containing this asset, master asset, or shot. It in both. On the right side is our update info that always pops up if a new asset layer gets pushed or published. That allows the artist to, in his workflow, to automatically update the new asset and bring it into his scene.
Yeah, and that's live. If you work on it in Maya and somebody else pushes something, then you get a little pop-up and informing you about the update, and then you can choose if you want to update like immediately or later and pin the asset. So that's really cool.
And this was super important because otherwise it feels like a black box to artists. In most work files, we directly work on a USD asset or shot. So we quickly noticed that this becomes an issue, because if a bundle or shot is loaded in your work file, the user gets its own edits into his scene through USD, what creates an unwished loop. For example, if an animation got published. The artist will see his own before published animation then in his scene. This becomes really an issue if he applies edits on object that does not exist. So, and will, because, for example, if FX got inserted already and the animator sees his scene, edits this, then it's technically not at the right place, and this caused issue because then changes came into the scene that can't be tracked very well. This is where our layer muting comes in place, where on default we mute all layers, self-including and higher order. But if wished, an artist can turn this off to see the final result in his scene. So, just at the beginning, we implemented the muting with USD code. Now, as you can see in the video, we hijacked the Maya muting window, so an artist can use the Maya native window to remove the layer muting that you can see here in the video. For those who were attentive, while unmuting the FX layer now, the geometry disappeared on the ship. This is because we automute heavy layers in our pipeline. For example, scattering, FX, and grooming to prevent a lot of viewport crashes, because that happened quite often if there's heavy data inside, prevent heavy FPS drops as well. So, enough of our basic structure implementation. Let's come to the cooler stuff, our actual workflows. As an example of how much we benefit from USD, let's take our current assembly build. That's our set build. But we can use it now more dynamic. So the pipeline integration is that we just offer an UI to quickly reference an asset that you have seen right now. What you can do with creating your own prim, then right-click, add reference. The rest is native USD driven by writing to disk a USD assembly layer through our publish UI that you can see here right now. For those who were attentive again, the assembly layer was in our asset layer order, the first layer in our layer stack. This is because we added what we call modified asset. With this, you could load geometry into Maya and modify it and then publish it as model layer. So some assets could be adjusted if needed, even if they are the same type. But this does not get used often because of our model variants. This is much more performant, and the artists prefer the model variant workflow in most cases. A little fun fact, what was before 1,660 lines of code is now 11 times less code to do the exact same thing with USD. So it's now 143 lines of code, just referencing assets and bringing everything out to make it usable in Houdini or load it later in Maya. So, as you have seen in the trailer, there was this Demeter ship, and already in our scenes, that actually was an assembly set. In our legacy pipeline, it would be a pain adding functionality for animating this ship. At least if we are not in Maya, and we are not only in Maya. But with USD and the and Autodesk Maya lib proxy accessor, it was possible to animate assembly sets live in a stage. How does this work? First, we built the rig by creating with our project explorer a rig file. This adds a simple prop rig setup with basic controls that can be adjusted in visuality. These controls kind of magically moves object in the USD stage and can be animated with keyframes. Here we select the stage, so you can see it's actually driving a USD stage and not the Maya node. It's driving the prim. Yeah, that you can add with keyframes, and you could maybe see in the attribute editor the values for USD are moving and actually are live in the USD stage. So the technical background of this is just this simple root controller rig that probably everyone knows who uses Maya for animation. This gets a parent constraint just to a locator, and this locator builds a connection into the USD proxy stage, which actually drives the prim inside the stage. Behind this is the so-called universal front end, or short UFE, this that you can describe as a listener to all live objects in the scene, and a bridge communicating with Maya to USD and the other way around. In general, a lot of people thought, or we thought, it is not possible to animate something in the stage, but it is possible with Autodesk and Maya to animate something in that stage. Here you can see the code for building this default setup, so it's not that magically. This worked fine until Ghosted kicked in. Here you can see a screenshot from that movie where this complete tower is rotating in all different kinds of angles, and in the end it's collapsing while spinning around. And here a much more complex environment came across, and the artists from the Demeter with the ship liked this assembly rig so much, so they wanted to push this further by driving deeper elements in the hierarchy using complex multiply divide setups, and even drive elements inside some assets from this assembly set. The only problem here is that we on default do instance, make prims instantable, and we had to turn this off to drive elements inside the USD stage through the proxy accessor. So next thing of this assembly rig is how to animate this in a shot context. So the first thing the artist has to do is selecting the root prim of the assembly set, then go to our rise shelves and load the rig. This rebuilds the connection that has been done before in rigging, and loads all the controller. With this, an artist can animate it in the scene. This, of course, only works with X forms, and there's no skin deformation possible. So if an artist now wants to load to make deformable animation, he can select the asset and click Load Related Rig to this in the shelf UI that you can see in a second. Yep. No? Yes. Now it's loaded, and this brings in a Maya native Maya file with the rig that has been built before, and it automatically follows the ship and the assembly rig, because we can do the connection the other way around, something from the stage inside a Maya node. So through the proxy accessor, and then the root controller of this must gets animated. If an artist now is finished with the animation at the end, let's wait a second, and everything looks fine. He just had to publish the scene. Now you can see our publish UI again. Here for the loaded Maya file, we just track the prim path where it should get over the animation cache, because we actually write for deformation animation and cache file. And maybe you have seen before, there's the is chunked option that got toggled on. This is something I tell you about in a second later. So how does the actual animation data from the assembly rig gets written out? So first we thought that we had to kind of loop through the timeline with code and track for each frame what values have been set on the prims, but then we accidentally saw an interesting behavior in this layer structure. So on the left you can see the Maya layer overview, and there's the session layer. And on default, if you start a scene, this is empty. But if you click in the timeline and print this layer again, you get already keyframes. So from every connection that has been done with this proxy accessor, and we kind of abuse this to loop once through the timeline, and then take this session layer and just write it out to disk, and animation done. Or writing the cache file done. So if we look at the code, you can, first we'll look at the file. This is the USD file that actually gets written out then. And how it looks, I just removed some keyframes, so it's not that long because it's really long range. And the code for this, doing this, is just this. So it's really, well, no Hexenwerk.
No rocket science.
No rocket science, if you figured this out once. So let's come back to the actual deformer animation, how we call it. Our normal the Demeter must, this normally writes a cache file using just the Maya plugin for the USD export plugin that Maya offers. As you might know, this contains always a full frame range, what produces huge cache sizes, so it's just the complete frame range written once. With CRUD from Guardian of the Galaxy, these became so big that all of our software did crash immediately while we load the caches into our viewport. Therefore, we added a single frame export that's called in USD terminology value clips that you can see here in our farm representing. These value clips can produce a per frame cache. There we tackled as well the issue that Maya would write for each geo and each frame, even if it's just an X form or a transformation data, the complete geo.
But it's not Maya's fault, right? Because
no,
it's not Maya's fault.
No, it's because we abuse and write a per frame cache, and it's not Maya's fault because the USD export plugin is not meant to get used like this. Yeah. So we wrote an own code to track these deform geo with an internal attribute that we add on each prim and clean this information if a geo object is not deformed.
We're basically removing a lot of redundant data that's not
afterwards, because you can edit an USD file afterwards just through the USD API quite easily. This is how the value clips look like in the file system. There's one main USD layer that references all the per frame cache data, and if you then load this into Maya, just the one frame gets loaded and then the viewport does not crash anymore. Yep. So the next logic conclusion after the assembly rig and the animation was that we wanted, or Ollie mentioned, we need a prop rig, because in the past we had to build for each simple prop and simple rig to make it to do some animations on them. But with this technique of the assembly rig and the assembly animation, we now can just load a simple prop rig into the stage that you can see here by just selecting the prim. Is it playing? No. Okay.
Don't worry.
It's crashing.
What's crashing? PowerPoint?
Yes. Choose PowerPoint. 1 second. Let me restart.
Any questions in the meantime while we reboot? Do we need the mic? Yeah? Okay, give it to him. Just ask.
All right, so yeah, two quick questions. One is for the asset resolver. Are you just kind of manually going through all the different layers of USDs, since it's nested USDs inside each other, to find out which versions hit or which versions unlock when you're sending it for rendering on the farm?
Now you got me. I have no idea. That's a question for Simon Ola, I guess. Or can you answer that?
Well, with this asset info prim, we know which version is loaded right now in the scene, and then we just write out an log file for that specific render that just keeps, that switches all the sim-linked master USD file to the fixed version. It's not.
Do you know how much adjustments we did to the rodeo resolver? Was that a lot?
Not that much. We just
Have
use
you
our
looked at
own
the rodeo
parts.
resolver?
Not yet.
Do that. I think it's going to answer your question. So it's just a minor adjustment that we did on their resolver. So, right, I guess we can go. Yeah, we have Q&As at the end.
So let's.
Do you really want to try again?
Yes.
Oh, okay.
It's 50-50 that it crashes at this point. So here again to our prop rig, that's technically that's just the same than before with the assembly rig, just now it's adding a simple controller deck and you can adjust or animate something in the stage live and then publish it later. Yeah, Ollie did mention this before, our variants, LOD and model variants. Because this is quite new in our pipeline, the LOD variant part, we can just use our pipeline development scenes for the demonstration. In a USD stage, you can only use the, as mentioned, the proxy or the render purpose, but not a mix of both. And having a mix of both of them is quite important for animators, like they want to animate on the ground with connections to the floor, but they can't because they just can see it in proxy or render purpose, and render purpose is too slow. So we added this LODs, like LOD 50 is the proxy, and LOD 300 in this case is our model variant, and with our rise shelves in the top that offers the option to switch them. You can see it in a second. Yes, here, to LOD 50, and then an artist can just pick one asset to switch it to LOD 300 if needed.
Yeah, I don't know if that was too quick, but the general use case is animation, right?
Yes.
So you have a large set that if you would load like the standard model LOD, like the high-res, your animators would not be happy with viewport performance and like everything like that. And most of the time, the animator is not interested in everything that's like far away from its characters. The only thing that you are mostly interested is ground contact. So you just put your ground to the model LOD 300, and everything else you put to 50, and you have very interactive frame rates. And yeah, that's just workflow enhancement, more or less.
Yes,
and this is not doable by just switching to the proxy purpose. That is the problem. If we switch to the proxy purpose, then also the ground would be proxy, and that's not what we want. We want basically a mix between render and proxy purpose, and I think this is something that also the people from Pixar probably need to address at one point. I don't know, because for us, the proxy purpose is kind of useless in Maya, because we want fine control about what you see in full detail and whatnot. That's it.
Yes. So maybe you did notice by using technically you can in Maya use the native USD camera, but there's some features missing, like for example you don't have an image plane, of course, and you can set the film back. That's quite important for framing for artists. So we as well here use the proxy accessor to take advantage again, but this way, the other way around. So we just we put out data from the USD stage and connect it to a native Maya camera that you can see here.
I think you just said film back. Did you mean image plane?
Film back and image plane,
okay.
Both. Yes. So here we have the film back, back. Not the image plane, because we are not allowed to show this, but it is working as well. Yes, and the good thing about this setup is this camera, this native Maya camera, gets automatically the updates from the stage. So if a new camera comes in, this native Maya camera gets through the stage already the updates. Yes, and this is how the setup looks like. So the only thing here so it just takes the proxy USD proxy stage shape and promotes the attributes on the shape, and then we can connect it to the Maya camera. The only thing to consider here is that USD attributes are not always the same than the Maya attributes, and you have to implement some switch logic for this. Just a little bit of math. Yes, and our last important tool is kind of a camera loader, we call this. It's where we enhance this technique to easily switch through different kinds of shots and cameras directly in the USD stage. We just reference in the camera prims, and then with this UI you can toggle through all these shots. What is really important for if you build an assembly build to see the assembly in the different shot perspectives. As well, you can then adjust these cameras and publish them back into their original shots if they are not matching 100%. Yeah, this was our tips and tricks and insights from our USD pipeline. The not so default stuff for some parts. Yeah, but there's still stuff to do. Right now, we are not using USD skeleton, and pretty sure we can further improve our animation data by using this USD skeleton. So we not have to write these huge caches and just write out the joint deformation. That should save us a lot of data. Yeah, like you have seen, our UIs for the users are not all very pretty and most likely just a shelf button to click. So we need to enhance this and give a clearer overview of what can be assembly loaded or what asset can be loaded to hand over a better UI. We are still using Python 2, unfortunately, in Maya, and we have to quickly change this.
Question, Sebastian. You are Python 3 already on your Maya pipeline?
We have everything else on Python 3 on Maya. It's 99%.
Okay, but also still in the process. Okay, yeah, we're still. Yeah, okay, so at least we're not the only ones that are like currently in the process of switching.
Yeah, because with Maya 2023, you need to use Python 3, and a lot of new features come in there that we already tested and are pretty awesome, but we can't use it right now, unfortunately. Over the time, we noticed that some difference between our asset and shot layer behavior exists, and now we know that we can unify them and to reduce our code base again. What's always a good thing. So we'd like now to finish by also mentioning some of the open source software used. Starting with Pipelish. Pipelish is the publisher UI that we have seen before. It's a plugin-based system to easily validate and extract elements from a work file, and we have customized it quite a bit. For example, we use a total custom UI, and we have also connected it to FlowPipe. FlowPipe is used in many of areas in our pipeline. It's a lightweighted framework to do flow-based programming in Python, kind of node-based programming. And in the USD pipeline, we use it to send our publishers to the farm in a very optimized way, and it makes sure that the individual Pipelish plugins are still able to share data when running on the farm. FlowPipe is being developed by our head of pipeline, Paul Schweitzer, so I definitely recommend to check it out on GitHub. FNSI is our render farm manager, for which we also run a custom UI. Then the USD manager, it's an open source by DreamWorks Animation. It is a USD browser and editor. It's super handy, and we connect it as the default application for all of our USD files on the file system. Then the Rodeo replaced resolver. Our asset resolver was initially based on it, and it does this substring replacement, just adding a version at the end to pin on specific data. Maybe now with the AR 2.0 becoming the standard, it might be a bit outdated, but it's still a great resource to get started.
No?
And finally, here is the wonderful group of people that worked on our USD pipeline over the course of that last 4 years. So big thank you to everyone involved.
Yeah, okay. No, that's good. Thank you, everybody. While Kolja was presenting, I had the feeling that this was a lot, very detailed information, maybe a bit quick. If you have like detailed questions, we can always follow up later because we only have like, I guess, 5 minutes left. So if you run into us later, just like don't hesitate to just say hi and yeah, have a more detailed conversation than what we can give you in the next 5-minute Q&A. So, other questions?
Yeah, so I had a quick question about the initial shot layers that you guys set up. Like I noticed that you guys split out basically the animation camera, the match move camera, I think there was a couple of cameras in there. What was the initial reason for doing that instead of not having one camera layer?
You're really smart because this is currently on the to-do list to overhaul this.
That's the unification of the unifying the shot and the.
No. That's a different story. So
Oh,
cameras right now, also because of our compositing part of the pipeline, which is not full on USD yet, we still we were forced to always write an Alembic cache in parallel to the USD files. And this is not feasible because you can do so much to cameras in other layers that in comp, they started wondering, why is my camera not looking in the direction like as the USD camera? It's like, yeah, because you're using the Alembic camera, and in the USD, somebody did a transform on your camera in the layout layer. And Nuke just doesn't know because the Alembic is the Alembic that got published. So we are currently, so the good thing, Nuke understands USD, and even Nuke 13.2 can read USD, and you can use the cameras from there. It's production proven. Luckily it works because we just found that this is not working. So we are going to have not one camera layer in the future. We will have the initial camera that comes from MatchMove, and then instead of always writing like monolithic files for every step of the camera pipeline, we will move towards layers, but additional layers. So, for example, layout can do a repositioning of the camera from the, let's say, LiDAR position to the position in your final set or environment. That is basically a standard 3D repositioning that you always do, like we call that LiDAR to set position. That would be one layer that would only contain one transform. Then there would be, of course, the match move always has the full plate that's coming from set, but the client usually has a different specification for the resolution we should be working on or we should be delivering. So this is another step of our camera pipeline where we basically calculate the crop of the film back that needs to be applied to go from the source resolution.
I love the details, but I would like to give the mic to someone else. But I will definitely come back to you.
Okay,
but you appreciate it. Yeah.
No. Too much detail. Let's talk about it later.
Yeah.
Sorry.
Yeah.
Sorry, I just was in a flow.
So, what are like your entry-level expectations for someone who would love to like join your pipeline development team?
Good question. So obviously USD is totally new, and I guess none of the new starters at RISE have any previous background on coding on the USD end. So if you know how to code, then you can apply. You don't need USD background. If you have a USD background, that's a bonus that will certainly get you a job. So yeah, does that answer the question? Or
yeah, like also more general, like for more like entry-level pipeline developers. Like if you, if there are some, like if you already have to be like a really good coder, or if you can also like do a train internship or something.
Yes, you know what? Come to our recruiting booth at 5 p.m. and then find me.
Okay, nice.
Cool.
Thanks.
Generally offer internships. Yeah. Right now we have one. Yeah.
So hopefully it's not too detailed, and cut me off if it is. But I saw that you were using value clips for animations. Are you doing something similar for, say, heavy particle effects stuff, where it's doing a single file takes forever on a single computer? And have you had any problems with motion blur when it comes to value clip stuff?
Yes, yes, and yes. Well, of course, this value clip, we coded this open for every DCC.
And we started implementing it in Houdini for FX specifically. That's what you need this there. And obviously there were a few quirks to figure out regarding motion blur, but in general this is not a problem. Like, we are using it in production for quite a while already, so there is nothing to be worried about. So just write your time samples, you're good. And this is also highly recommended. Like, you don't want to start a USD pipeline without having value clip support, because you're running into trouble right away. It's like, if you yeah, it's just like you need value clips. If you take something away from this, you need value clips. Definitely.
True.
We learned that the hard way. Any more questions?
Hi. What is the current status of the connection to Shotgun, or did you have any specific challenges?
We have no Shotgun.
Yeah,
we have our own in-house organization too.
So everything custom.
Yeah, it's basically as old as the company. So there's some the management is so in love with this asset management or production tracking system. We have tried to convince them to use Shotgun, but not happening anytime soon.
Thank you.
We store the information of which version was used in which USD still in your array space, or
yeah, it's all in the database. Yeah, we have asset relations on the database where you just point to other assets. It's I think in theory you could do that without a database in USD, but by just
you could use a file-based database, for example, just reading the USD files, but we still track it with our database, the same information.
Just quicker. Guess that's it.
Thank you, guys. Yeah.
Thank you.